Air Force One plays a critical role in transporting the president and his staff across the world, and over the years, the aircraft has evolved to match the ever-expanding world leadership role. Today, we will look at the Air Force One's humble beginning, its modern implementation, and what the future aircraft are under consideration to fly the Commander-in-Chief. Hey, it's Nick here from Found and Explained. If you like what you see, then jump on and subscribe. Air Force One's story began in 1933 with the Douglas Dolphin, an amphibious plane owned by the US Navy and designated the RD-2. It was fitted with a luxury upholstery for 4 passengers and a small separate sleeping compartment. While it only had a range of 601 nautical miles, there are no actual reports that any president actually flew in the plane between 1933 and its retirement in 1939. When World War II broke out, the presidential transport was upgraded to the Boeing 314, a Pan Am-operated flying boat called the Dixie Clipper. It flew then-President Franklin D. Roosevelt from Washington to Casablanca, Morocco, over the Atlantic on a journey of 5,500 miles in 3 legs. Planes were favored over ship transport thanks to the U-boat's genuine threat in the deep Atlantic during the war. While other military aircraft were used in the years following, the first aircraft to actually hold the name of Air Force One was the Lockheed VC-121A LO Constellation named Columbine II.
The Lockheed Constellation, world's largest land-based transport plane, prepares to make its first public flight.
It could fly its VIP passenger to a range of 4,700 nautical miles, and it was used from 1962 by President Eisenhower to the beginning of the jet age. In 1959, 3 specially built Boeing 707-120s jet aircraft, also known as VC-137 Stratoliners, were added to the Air Force's VIP transport fleet. The VC-137s were powerful additions, flying 7,610 miles and could carry up to 22 VIP passengers, and act as a flying command post. They could fly twice as far in the same amount of time as the previous Lockheed Constellations. These 3 original Boeing 707s operated for a president until 1962 with the purchase of the first true presidential jet. A custom-made Boeing C-137 Stratoliner called the SAM 2600 was built for $8 million. This was also the first plane to actually have the famous baby blue presidential color scheme. SAM 2600 would be used from 1962 to 1998, although it served as a backup aircraft to a new VC-137 design in 1972. This new aircraft, called SAM 2700, would serve until 2001 as the de facto presidential transport aircraft. In 1985, however, the United States Air Force issued a request for proposal for 2 wide-body aircraft with a minimum 3 engines and an unrefueled range of 6,000 miles. Boeing entered the contest with its Boeing 747 and McDonnell Douglas with the DC-10, with the Reagan administration going for the bigger order of 2 identical 747s to replace the aging 707s he was currently using. This Boeing 747 VC-25A would be formatted to carry 26 crew members and 76 VIP passengers, including the president and all of their staff, to a range of 6,800 nautical miles. This was no ordinary Boeing 747, however, as it had been formatted to survive an EMP attack and also act as the flying center of government of the executive branch. It also has the ability to deploy its own stairs in case it lands at an airport without stair transportation. 2 such Boeing 747 Air Force Ones have been constructed at the cost of $325 million each and entered use in 2001. From here, the Air Force has been considering several options for next generation of Air Force One aircraft. At the time, the government wasn't opposed to looking overseas to Airbus with its Airbus A380 platform, which has around 40% more interior space than the Boeing 747. Although politics would have prevented anyone but an American manufacturer from making a real bid for Air Force One, it was certainly an interesting proposal. Another hot contender on the table was the Boeing 777X. The next generation aircraft would have the highest range of any presidential aircraft and have the advantage of several new features. It would lose some floor space compared to the Boeing 747, but it would have a range of 11,645 nautical miles, enough to fly almost anywhere in the world. In 2016, proposals to build a new aircraft from scratch were rejected, thanks to the enormous cost, and a new plan to retrofit two Boeing 747-8 Intercontinentals that were never delivered to a Russian airline were put on the table. These new planes were flight tested but never delivered to the bankrupt airline. With a few modifications of the layout, wiring, and EMP protection, these planes could replace the current Boeing 747s and begin a new presidential transport generation. The 747-8 Intercontinentals will have a minimum range of 7,730 nautical miles, although likely a lot more thanks to the smaller passenger capacity of around 100 VIP travelers and extra fuel tanks. But the story doesn't end here though. The Air Force is also looking beyond the next generation into a supersonic future. They have proposed 3 different firms, Exosonic, Hermes, and Boom, to build a supersonic Air Force One that can transport the president across the country in a matter of minutes, not hours. Boom, the current leader in the supersonic race with the only existing prototype, would develop a 30-seater VIP supersonic transport that can fly a range of 4,500 nautical miles at a speed of Mach 2.2. The first aircraft is expected to fly by 2029, but once proven, a presidential transport is not far behind. Although at this point, if you start to wonder if the Air Force has considered other crazy proposals like the Elon Musk spaceship that can reportedly reach anywhere in the world in only 45 minutes, although perhaps even that is a bit too far-fetched for even the most powerful job in the world. Thanks so much for watching today's video. It has been a great project to work on in recognition of the 2020 election, and I hope now after watching you are more clued in with the journey of the US Air Force One aircraft. And if you enjoyed the video, then I suggest you leave a like, comment, and subscribe. And I can't wait to see you in the next video. In the mid-80s, one man had a dream of an Ekranoplan that would be almost 10 times bigger than that of the Soviet Union's Caspian Sea Monster. After all, everything is bigger in America. It was so large that it was essentially a flying city, with enough seats for thousands of passengers, enough room to house everything from hospitals to 5-star dining, or given military application, hundreds of tanks, and perhaps even carry nuclear warheads. But why? Why was it planned? And who was the madman behind this fever dream? And why was the military reluctant to replace aircraft carriers forever? This is the story of one of the largest aircraft ever designed, the Aerocon wingship. Our story begins 20 years earlier with the rise of Boeing, rocket roll, and the Ekranoplan. Spies had reported a new type of machine deep within the Soviet Union that was so advanced, so cutting edge, that it started its own category of aircraft. By using what is known as the ground effect, the Ekranoplan could ride a bubble of air above the waves, faster than a boat and carry much more than a regular aircraft. In fact, it was predicted that there would be no upward size limit for such a machine, and the Soviet Union was already planning everything from troop transports to aircraft carriers. And all of this wasn't lost on the Americans. In fact, one American in particular got totally obsessed. Stephen Hooker was this man. Hooker was an aeronautical engineer whose obsession was first stoked with Ekranoplans when he witnessed the famous Caspian Sea monster in 1967. Hooker was working with the Defense Intelligence Agency, or DIA, at the time that discovered what the Soviets were working on. He became so convinced of the potential of this type of aircraft that he resigned from his post in 1983 in order to design and develop a viable American version. By 1984, he had founded his company, Aerocon, in order to develop a ground effect aircraft with a formidable cargo capacity for both military and commercial passenger payloads. Hooker wanted the craft to have the range of a small ship, and being a ground effect vehicle anyway, called his concept the wing ship, which is why the term was adopted in the name of the project. His vision was simple and even a little mad. He wanted to build an Ekranoplan that would be almost 10 times bigger than the Soviet Union's version, and this is exactly what it looked like. The Aerocon 1.6 wingship was on a scale that could only be described as massive, even gargantuan. Consider its payload alone, which was no less than 1,400 tons. That equivalated to the ability to transport 3,000 civilian passengers during peacetime, or for military purposes, haul 2,000 troops, plus helicopters, tanks, landing craft, and other military hardware, such as armaments. A test example of its cargo capacity is worth highlighting, and it makes quite the list. 32 helicopters, 20 tanks, 4 landing craft, 300 rounds for howitzers, and that's not counting the 2,000 troops and their equipment and food that was included in the manifest as well. To fly this all airborne, it would have been powered by no less than 2,400 kilonewton engines, enough to power the Aerocon 1.6 to a range of 10,000 nautical miles, or make that 18,500 kilometers with a maximum flight distance. That's a very big range for a very, very big aircraft. This capacity and range would allow the US military or its civil applications to project force or fly passenger routes almost anywhere in the world at a moment's notice. Imagine 2,000 soldiers showing up at your door 8 hours later. That's how incredible the design was. It was so big that the Aerocon 1.6 had impressive stats as well. The aircraft would stand at 34 meters tall and be 173 meters long. It would boast a wingspan of 100 meters with a total wing area of 3,597 square meters. Aerocon contended that the airship's large, wide wings would provide it with a clearance of waves of up to 6 meters or 20 feet in height. This would allow the airship to operate perfectly well over quite rough seas if needed, something that had always plagued the Ekranoplans of the Soviet design. By way of a comparison, the Aerocon wingship, with a total weight of 1,627 tons, would be over 12 times the weight of a Boeing 747, but critically, it would be able to carry 30 times the payload than the Boeing aircraft could, which again is why the US military was so interested. Aerocon argued that because it weighed so much, 5,000 tons when fully loaded, it would be highly efficient because the induced drag is reduced when closer a wing gets to the surface, such as water. The large, wide wing of the Dash 1.6 wingship would ensure optimized surface ground effect with very little induced drag. This result would also be more fuel efficient per ton of payload than anything flying in the sky today. And you're probably thinking, Nick, this huge thing must have been very slow. It would actually fly at a top speed of 741 kilometers per hour and be able to fly up to 4,600 meters, which is understandably quite low by aviation standards. But considering it was designed to take full advantage of the ground effect, it is very unlikely that they would have ever used this flight model. Aesthetically, it was somewhat ungainly in the opinion of some people at the time. The Aerocon airship looked like a cross between a space shuttle and a Caspian Sea monster. So not very attractive, but boy were those payloads attractive. So why wasn't it built? Hooker and his company Aerocon successfully lobbied Congress to consider the viability of the 1.6 wingship. The 1993 Defense Appropriations Act provided $5 million to the Advanced Research Projects Agency, or ARPA, later referred to as DARPA, in order to determine the military viability of the wingship. Particular focus would be on the craft's ability to increase the airlift and sea lift capabilities of the United States military. So they could knock on the door of the next dictator by dinner time. By June 1995, ARPA released a report which estimated that 13 of the wingships manufactured by Aerocon would cost the US taxpayer approximately $15.2 billion, which was shown to be the equivalent in cost to 63 C-17 cargo aircraft, 69 fast sea lift ships, or 102 C-5 cargo aircraft. The bottom line, the Aerocon Dash 1.6 wingship would be as an expensive as proposition as it was huge in size and payload. The DARPA report found that the proposed ground effect craft was at least 5 times larger than what was recommended by American and Russian experts, some of which had actually worked on the original Akrana plan. The current technology, that is of 1995, simply wasn't available to build so large a ground effect craft. The report therefore concluded that the project was not technologically or financially viable, although it did conclude that there would be promising military applications for wingships in the 400 to 1,000 ton range, so approximately 5 times smaller than our boy here. DARPA, however, did have to admit that the costs of the project were difficult to ascertain precisely, given the proposal technology was so new and unknown. One DARPA team member was even quoted as saying, "It's like asking the Wright brothers how much a 747 would cost." Nevertheless, the Aerocon proposal was rejected, never to be considered again by the US military. Which you might agree is a dying shame. This aircraft is unlike anything you have ever seen. A 2-part tandem aircraft that could transfer passengers between them, fly across America, and change the very business model of air travel. The possible benefits foreseen were superior performance, comfort, and service, as well as reduced congestion. And by the end of this video, I guarantee you'll be a believer that this is even better than flying today. I'm absolutely serious. This, my friends, is the Aerial Relay Transport System, or in my mind, the Flying Train. Our tale begins in the year 1979, and air transport in the United States is off in a big way. Planes are getting bigger, airports are getting larger, and American passengers are getting, more frequent fire miles. Thus, NASA was tasked at projecting the future of aviation and predicting any roadblocks that might be coming up in the near tomorrow, as to better prepare airlines and aerospace manufacturers. The report, dubbed NASA Conference Publication 2036, made a ton of fantastic discoveries. Everything from recommending winglets on planes to supersonic passenger jets, and even advocating an advanced turboprop for all short-haul operations. But it's the hidden aerial relay system that's the most fascinating and, honestly guys, the most insane idea I've ever read. Dubbed ARTS for short, it was developed by Albert C. Kaiser of Langley Research Center, but you don't care about that, you want to just see how it all worked. This system, or train as I like to call it, consisted of two separate aircraft. The first is a large continuous flying liner that operated in conjunction with small feeders. A typical passenger journey would start with them arriving at a regional airport and boarding the feeder aircraft. This feeder aircraft would then take off and link up with an already in-flight liner. The passengers would then dock to the rear of the liner, passing underneath the cockpit of the feeder and board through the tail, taking a seat on board. The passenger would arrive at the vicinity of their trip origin and then depart on a different feeder in the vicinity of the destination. Simple. The liners would take on multiple feeders throughout its trip, and there would be several different liners on different tracks across America. But I'll get to that in a moment because I'm about to drop a bombshell. These liners could actually merge into a mega aeroplane, just like one of those early 90s cartoons with the giant robots. The liner itself is a system of aeroplanes that may be regarded as modules. These modules would take off and climb as individual aeroplanes and link up once they reach cruising conditions. In this way, extremely large wingspan liners could be built up without requiring runways of an equal width. The module approach has other potential useful features, but I'll also get to that in a moment. In this case, a liner would line up next to another and use powerful electromagnets to dock together. Once the seal was completed and the two aircraft mated, the airlock would open and the controls would be handed over to the prime aircraft. And insanely, there would be no limit to how many liners could dock up together. With 3 of them, it was estimated that it could carry over 800 passengers coast to coast, with passengers able to transfer between each aircraft. These liners would be designed to have 4 engines to ensure that there would be double the thrust required to maintain a stable connection. But the report clearly states that in emergencies they could quickly detach. The span loader design was chosen for maximizing passenger room and enhanced passenger comfort, but I couldn't exactly figure out where the windows would be, so maybe you can let me know down in the comments. But now I know you're asking, where would these aircraft fly? Well, put it this way, a train runs on tracks and this flying train wouldn't be any different. Multiple different track configurations were considered by the study, the most simple being Los Angeles to New York. This straight-line track across America's sky would serve cities such as Las Vegas, Denver, Chicago, and more, with feeder aircraft meeting a liner in flight. These feeders would have a range of up to 400 kilometers or 250 miles, so given enough time, the range was quite substantial to meet the liner in flight. A single liner on its own could serve a region of about 500 kilometers or 300 miles as it traveled along its track. Ideally, the liners would begin and end at each city pair and express services could be offered. This single track with multiple liners would have around 65,000 seats a day and would be far more efficient than the current point-to-point model that's the base of air travel today. And God, are you ready for some crazy numbers? The study proposed that an airline, such as American Airlines or United, start with a fleet of 42 liners and 130 feeder aircraft to cover the simple straight line from LA to New York. Since the bulk of the existing traffic occurs during the daylight hours, a larger fleet would eventually be needed. A reasonable projection might be 200 to 300 liners from 1990 to 2000 for this one initial route. The existing traffic is remarkably uniform along this route, so the liners would be well utilized. As the route network would slowly develop, the service could improve in both frequency and flexibility. After a number of major routes have been developed so that major intersections occur along the route network, it might be desirable to carry the in-flight transfer concept another step by having the multi-module liners exchange modules en route. A 3-module liner would split as it flew over Atlanta, for example, with one heading south, another north, and one west. This means, drumroll, hub airports are totally eliminated. Schematically, in the case of 3 routes meeting at a point, 3 liners could be scheduled to arrive simultaneously, separate, and recombine in such a way to comprise 3 new liners leaving that point, like a Rubik's Cube rotating in flight. The value of such a maneuver is that the passengers could be transferred from one route to another. For example, the path of a passenger who leaves Houston transfers in flight to another module and then eventually arrives in New York, even though no single module makes that particular trip. Isn't that incredible? Who doesn't want this? The study believed that in the end, the airline would have a vast flying railway network across the skies of America. For the passenger, this means a reduced total travel time by avoiding layovers on the ground. It also means a reduced airport congestion. On the average, today's passenger must make 2 landings and 2 takeoffs per flight, but with the aerial relay transport system, only 1 takeoff and 1 landing per trip would be required to go across America. Ideally then, this should lead to a reduction of 50% of traffic across the country, which you can imagine that even back then is a ridiculously huge claim. The report concluded that travel time and airport congestion aspects of ARTS seem to justify further study, independently of any cost or efficiency considerations. It also recommended more research on the operation of such a system, including scheduling, tip coupling maneuvers, the response of the multi-module liner to guests, weather effects in general, fuel reserves, and emergency conditions, and the automatic control of the entire liner fleet as a system. So what on earth ever happened to our insane flying trains? As in true found and explained fashion, there are some flaws with this concept, and using the power of hindsight, we can examine it through the lens of today. First of all, aircraft travel is the safest way to get around in the world, and any aircraft design that makes things inherently more risky is inherently shut down. This design, with its mid-air docking, would be so dangerous and so many things could go wrong that it would never leave the drawing board. There is just too much risk, despite the benefits, for it to even be considered. Secondly, the liner design is massively flawed. Ignoring the fact that there seem to be no windows, we also need to consider that the low aspect ratio and huge squared off tips would have massive drag and generate huge turbulence behind and to the sides of the aircraft, which funnily enough is the exact places that the other liners and feeders need to travel through. Plus, there is this false assumption that passengers only want one thing: point-to-point travel by aircraft where they can sit down and enjoy a movie, eat what passes as food, and get to their destination without having to transfer in any way. While the aerial relay system seems to be brilliant, it would have gone the same way as hub-to-hub travel is going today, because airlines know that they can just have a direct service with no stopping, no other boarding, and no other interruptions, and it would be far more popular. On a lighter note, you could only imagine how many FAA officials had a complete heart attack reading this report, and maybe it's best it just stayed as one. What do you think? Subscribe if you haven't and let me know down in the comments. This is no ordinary jetliner. Carrying 119 passengers to a range of over 1,200 miles, this plane matched those from both Boeing and Airbus, but with one secret weapon. It could fly vertically. With 16 fans built into its wings, this insane plane design was set to change the way we travel, how city airports were designed, and believe it or not, make air travel 10 times safer. This is the incredible Hawker Siddeley V-STOL jetliner. The Jet Age. Oh, what a magical time that was. Aviation really took off in the post-war era of the 20th century. By the 1960s, the jet age was in its heyday and flourishing. Wider-bodied commercial aircraft were becoming faster, flying higher, and jetting away to further destinations over the horizon. More and more people were hopping onto planes, not only for business travel, but for leisure as well. This innovation led to planes to become more fuel efficient as well, which only upped the ante on the commercial aviation boom. The focus was not only on longer haul flights, but also on the fast growing sector for short haul efficient flights between cities. It was these flights that were especially attractive for business travelers. Aviation companies and airliners alike knew that the race was on for city hopper flights. So it was no surprise that the British Transport Aircraft Requirements Committee, or TARC, T-A-R-C, issued a design study outline requirement in 1969 for a short-haul aircraft to be developed by a British aviation company. The brief was for a 100-seater airliner with a minimum range of 450 miles or 725 kilometres. That would be the range enough for flights like Glasgow to London or from London to cities like Dublin, Paris and Brussels. But not for cities like Rome and Berlin, so very short range indeed. The Hawker Siddeley threw their hat into the ring with a jetliner called the HS-141 that had a radical new feature. It could take off vertically. A central and unique facet of the outline requirement issued by the TARC in 1969 was that the aircraft had to be a S-VTOL airliner. A vertical and or short takeoff and landing or VSTOL aircraft is a plane that can take off or land vertically or do so on very short runways. Therefore, it is obvious that a VSTOL aircraft has to have the ability to hover. A subset of this unique class of aircraft is the vertical takeoff and landing or VTOL aircraft that doesn't require any runway at all. The military had been the primary pusher of this technology forward in the post-war era, since they wanted fast jets that could be operated from clearings in forests, very short runways, or even small aircraft carriers, unlike other military jets that required longer runways and clearance for liftoff. Furthermore, VSTOL aircraft could go further and use less fuel than most helicopters. For civilian or commercial operators, VSTOL airliners were known to cost more per flight than a conventional airliner, and thus hadn't been very popular for research and development. However, these costs were offset by a VSTOL aircraft's greater convenience and productivity. Critically, they were also considered a lot safer, in that fan lift engines could provide adequate control even in the event of failure of the aircraft's main engines. In fact, VSTOL aircraft were considered 10 times safer than the standard provided by the UK Air Registry Board at the time. It's quickly worth noting that only aeroplanes that achieve lift in forward flight by planing the air can be classified as a VSTOL aircraft. That means that helicopters are not actually considered to be a VSTOL or even a VTOL aircraft, since they do not achieve forward motion in the same way. It's further worth noting that most VSTOL aircraft designs were abject failures from the 1950s into the 1970s. The very few success stories were military aircraft, including the British Harrier jump jet, released in 1969 and developed by the very same Hawker Siddeley. Another successful VTOL military aircraft at the time was the Soviet Union's Yak-38 Forger, released in 1971, which I think, if you know, definitely deserves its own video on this channel. So why was the British Transport Authority so insistent on this new design being a VSTOL aircraft? The reasoning was that a steep approach and departure profile would attain two things for air traffic in London at the time. The first was a reduction in noise in what was a heavily built up and major metropolitan area, and the second, it would mean that not having to build a third major airport in the London area. And so, a VSTOL aircraft it had to be. Founded in 1934 as the Hawker Siddeley Aircraft Company, Hawker Siddeley Aviation was by the early 1970s one of the largest British aircraft manufacturers, and so was a perfect choice for the new VSTOL airliner. The project was done under the auspices of Hawker Siddeley's Research and Future Projects Department at Hatfield in Hertfordshire, England. The design team investigated various configurations of the aircraft, as well as different power plant and control systems. The team was so enthusiastic, it submitted a draft design to TARC in January 1970, mere months after the brief had first gone out. Official details of the newly named HS-141 project were first issued by Hawker Siddeley at the German Aviation Show in Hanover in March 1970. The HS-141 design had the following design characteristics. It was to be an all-metal construction with a T-tail and low-mounted swept wing with a quarter-chord swept back set at 28 degrees. It would be 29 feet and 10 inches, or 9.09 meters in height, and 120 feet, or 36.63 meters in length, which meant it would be similar in size to the smaller commercial airplanes of the time, such as the Boeing 367-80 or the Convair 8800, the Lockheed L-1049 Super Constellation, or the Tupolev Tu-134. By comparison, that length would have made the HS-141 about 44% of the length of the contemporary Boeing 737 and Airbus A320 models, so it was definitely a small plane. Its wingspan was 75 feet or 22.86 meters, with a wing area of over 1,000 square feet or 98 square meters. Its empty weight would be over 110,000 pounds or just over 50,000 kilograms, with a maximum takeoff weight of 134,000 pounds or 60,000 kilograms. Inside, the plane was pretty conventional, with a passenger cabin with rows of 5 or 6 seats each, with it slated to have a capacity of 102 to 119 passengers, depending on the density of the seat configuration. We can totally imagine what Ryanair would do with this plane. Of course, you're likely wondering how on earth it took off right into the sky. A VSTOL aircraft clearly needs powerful engines, especially for lift. The HS-141 would have had 2 wing-mounted cruise engines and 16 lift engines mounted on either side of the fuselage, meaning there would be 8 lift engines per side. The Rolls-Royce RB220 turbofan would be the preferred engine for the forward propulsion, and the Rolls-Royce RB202 turbofan engines would be used to provide the much-needed lift. That engine power meant that the HS-141 was expected to reach a maximum speed of Mach 0.92 and a cruise speed of 432 miles or 694 kilometers per hour. A range of 1,200 miles or 1,932 kilometers meant that the HS-141 could go considerably beyond the range requirements requested by the British authorities in their 1969 brief. Design-wise, it was clear that the engines needed as much aerodynamic help as possible. High-lift devices such as flaps blown by the cruise engines were considered as a possible solution. Unsurprisingly, having so many engines was a huge headache for the Hawker Siddeley design team, given that they accounted for 15% of the total weight of the aircraft and a whopping 35% of its overall cost. A further issue was that Rolls-Royce themselves were under considerable financial strain, as were most British industrial companies in the early 1970s. In fact, Rolls-Royce declared bankruptcy in 1971, such were its financial woes. But an even bigger headache than the engines was the aircraft's flight control system. Particularly tricky was the control of the aircraft when in slow or hovering flight. The solution was to swivel the lift engines in their mounts and vary the thrust of each engine, thereby controlling the pitch, roll, and yaw of the aircraft as it hovered. Several tests using a 1/10 scale model of the HS-141 were run by Hawker Siddeley in their wind tunnel, using several different test rigs. For example, a thrust deflection rig was used to identify nozzle shapes and develop suitable thrust deflectors, which was critical for the aircraft when hovering or at very low speed and altitude. A large fan was used in the wind tunnel to aid an all-important noise research, whilst gas-generated fans were pod-mounted at the wing root trailing edge of the model to test the aircraft's lift parameters. An interesting side note is that several tests of the aircraft with STOL capabilities were being undertaken at the time, with an eye on the hugely busy and rapidly expanding northeastern air corridor of the United States. Eastern Airlines were particularly gung-ho about this possibility and even put out a specification for an STOL aircraft. However, this event would happen just before the energy crisis of the early 70s, meant that Eastern Airlines would never fully pursue its plans. There were many reasons why the Hawker Siddeley HS-141 never developed beyond scale models. As already mentioned, the economical climate at the time couldn't have been worse. Economic recession was already gripping the UK in 1970, and the oil crisis of 1973 plunged the entire world economy into recession. It got so bad in the UK that the country experienced something it had never seen before, namely stagflation, which was when prices kept spiraling up even during economic downturn. Also, the financial crisis at Rolls-Royce in 1971 didn't help, since it had to shelve its fan-lift engine, the RB202. The engine had not only been an essential component of the British VTOL airliner, but even the German one being developed as well at the time. This was a huge pity, given that the Rolls-Royce engine had achieved its needed thrust-to-weight ratio, fuel consumption, and noise characteristics with flying colours. As for Hawker Siddeley themselves, it would be one of the three British companies amalgamated in 1977 into the nationalised British Aerospace Company, or BAE. Its subsidiaries in locomotive building and diesel engine manufacture continued until 1992, when the company finally became defunct. Hawker Siddeley had been a proud name in the illustrious pantheon of British aviation manufacturers, a company that had once produced the Spitfire, the ace fighter plane that was the star during Britain's valiant defence against Nazi Germany during the Battle of Britain. It had also produced the famous Hawker Hurricane fighter plane and a host of other military and civilian aircraft, badged with names of companies owned by the Hawker Siddeley Group. Looking back at history where the city hopper market went, one can only imagine how powerful and game-changing this aircraft would have become. We would have seen smaller city airports built right in the heart of metropolitan areas, catering to business clientele and whisking them away to nearby country estates. There would have been a magnitude of different city hopper airliners operating throughout Europe and the coastline of America, allowing people to get to where they need to go as quickly as possible. This may have also eventually led to the rise of more urban VTOL aircraft, like the ones that we constantly see today, toted at tech shows with fancy 3D renders that have yet to see the light of day. As for the hero of our story, the HS-141, it never went beyond a 1/10 scale model, which means a full-size prototype was never produced, nor a single plane ever manufactured. Eventually, other city hopper short-haul planes would be developed by the likes of Boeing, Airbus, Embraer, and Bombardier. The HS-141 was not to be one of them. If you feel angry about what happened to this plane and you want to change the course of history, well, fear not, because you can change the course of my YouTube channel. That's right, by becoming a Patreon today, you not only get to suggest topics and vote in how they go, you also get to see videos early and communicate directly with me in our private Discord server. So jump on over to Patreon and see if it's for you, and I can't wait to see you in the next video. Do not adjust your phone screen. You are witnessing the plane of the future. It's huge, can carry over 1,000 passengers, and it might be arriving at your local airport very soon. Or perhaps not. In this video, we'll be looking at a triple-decked aircraft. Why don't airlines fly them? What would they be like if they existed? And why we will never see them again. Let's jump into this never-built video.
If you're new to the channel and checking it out for the first time, then subscribe if you like what you see for weekly aviation videos. Now, before we start today's video, I do have to stress that yes, there are technically triple-decked aircraft flying in the form of the Boeing 747 and Airbus A380 today. As in, they have 3 levels, 2 for passengers and 1 for cargo on the lower deck. What we're talking about is an aircraft with 3 levels for passengers throughout the plane, and then in addition, a cargo deck on the bottom. Truly a gargantuan aircraft monstrosity. This aircraft design would be able to accommodate well over 1,000 passengers in 3 different classes, with the very best in first class having their own private suites for long-haul flights. Other features may include rentable bunks like a Japanese pod hotel, an onboard spa for passengers looking to relax, a business center to keep working whilst in flight, bars and dining establishments for airlines to earn additional revenue, and even gyms. Although, as we have said in our future aircraft cabin concept video, the idea of a gym on board is perhaps not the best idea without access to showers. And plus, would airlines really want to carry the extra weight of dumbbells on board? Of course, knowing airlines, they would more likely use these triple-decked aircraft in an all-economy configuration, cramming in as many passengers on board as possible to try and earn as much money as possible. Let me know down in the comments if you would fly on a high-capacity version of the plane. With regards of where this aircraft would fly, the plane would be exclusively long haul, making sense only for flights across the world from Asia to Europe and to North America, between major hubs like Singapore, Dubai, London and New York. These planes would carry so many passengers that it would require a high density, high demand route. Lighter routes would make no financial sense, and domestic short haul routes, even New York to LA, would be impossible. So likely you're halfway through this video and you're starting to wonder, hey Nick, this is well and good and I'm enjoying the animations, but surely this concept doesn't actually exist. Well, during the research of this video, we did actually come across a few pretty insane triple-decked concept aircraft. The first is the AWWA Skywhale. Now this plane is totally bonkers and relies on technology that's beyond even the latest James Cameron film.
I kinda hoped you'd say that.
But we could admire the artist's vision for an aircraft that is truly of evolution beyond what we currently have today. The plane is a different take on what is known as the Breurgent range equation, rather how to fly as efficiently as possible. They are propulsive efficiency, how efficient your engines are, aerodynamic efficiency is how the lift is maximized and drag minimized, and structural efficiency, how much payload the plane can carry. Airlines naturally want the best engine and high aerodynamic efficiency, but they want to carry as much cargo, be it post or passengers, as possible. While the tube and 2 engines model has proven to be a great concept so far, has the airline industry become stuck in its ways and only relying on a design that is well over 60 years old? Second, we have the more conservative Deck 3 concept that can be built today with current technology, seemingly a marriage between a Boeing 747, Airbus A380 and an Antonov AN225 Mriya. This design seems to be the jack of all trades, but the master of none. With 3 engines on each side, it requires so much fuel to fly that any airline CEO considering operating it would seriously need to check in for therapy. It would have 3 decks and would fly slower than normal commercial aircraft to reach a peak of fuel efficiency. The last concept on our list was one by Airbus considered back in 1996. Called the Airbus A2000, it could carry 600 to 1,000 passengers, in which economy class passengers would sit on the top deck of the 3-decked aircraft, business class passengers in the middle deck with 3 aisles, and first class passengers whom beds would be available in the lower deck. The Airbus A2000 was intended to have a range of around 8,000 miles or 13,000 kilometers. Ultimately, this project evolved into the Airbus A380 that we know and love today. But what about if we brought this triple-deck concept to the current market using the aircraft that we have today, like the Boeing 747 and Airbus A380? After all, that cargo deck could just simply be repurposed for passengers like it has been done so in the past. The Lockheed Martin L1011 had an option to turn its forward cargo deck into a boarding lounge with its own featured stairway. Passengers could board without a jet bridge from the tarmac, save the airline money, drop off their coats and have a cocktail before moving upstairs to their seats. Another example of the cargo area being used for passenger services is the Airbus A340. This plane not only had bathrooms on the lower level of the plane, but also a galley with room for several passengers. It even had safety equipment such as seats and masks for passengers who are in the space during an incident. Alas, for those hopefully to fly in a floating city, there are several factors that make bigger aircraft than the A380 very far-fetched indeed. The first is aircraft flexibility. As mentioned at the start of this video, these aircraft require substantial routes to operate on a profit, such as flying halfway across the world. Outside of these routes, they will not earn a dime for the airline despite costing well over $500 million to buy and even more to operate over its lifetime. Without guaranteed flexibility, like seen with smaller twin-engine jets, airlines might not buy into this triple-stacked pie. And passengers seem to prefer the twin-engine flexibility, choosing between multiple flights in a day and leaving close to the time that they want to is more important than jumping on a single service once a day. Speaking of service, airports will have trouble getting access to the plane in order to stock it with food and fuel, with no ground cars able to reach that third level. Airports will also need bigger and longer runways to land the planes, impossible for airports like Heathrow and JFK, which already have space problems. Not including significant redesigns for taxiways, jet bridges, and parking ramps as well. Lastly, being a passenger on board, you could expect long boarding and disembarking times, a serious evacuation risk if you're involved in an accident, and don't even consider getting a meal whilst it's hot. Before we go, a special mention of the Boeing 314, which had 3 decks and was the mainstay for travel around the world for many years. But we'll do a video on this incredible aircraft and where it flew another time, so you'll just have to subscribe and tune in next time for that video. And if you're looking for a way that you can support the channel more, we also have now got a Patreon in the description that gives you access to videos early where available, live streams, discussions, and I'm also working on getting all of these custom models that you have seen here into flight simulator programs. So stay tuned for that. And this last comment may seriously date this video when it comes out, but thank you again so much for all the lovely subscribers that have allowed me to reach 20,000. Without you, none of this would be possible, and it has been an absolutely incredible journey. So from the bottom of my heart, and this is me going completely off the script right now, so I hope you're enjoying Nick from Found and Explained completely ad-libbing. Thank you so much for watching.
Flight 122 is in trouble. A broken engine and running out of fuel, it looks like they might have to perform a water landing. That is, until our hero arrives. This monster of a plane is officially called the P. Brooker Flying Landing Platform, but I call it the Plane Plane. Matching the speed of our ailing 737-100, the aircraft rises and grabs hold of the plane, securing it tightly. The plane then turns and brings the 737 back to Earth safely, landing without incident. But this rescue operation was only one use of perhaps the most versatile airframe ever built, with everything on the table from military ideas, oversized cargo, and even an insane use to catch space rockets from the sky like an aircraft carrier. Oh, and I forgot to mention, they also planned for it to take off vertically.
This aircraft concept is so wild that I couldn't wait to show it to you today, and I hope you're ready to explore the nutty world of the plane plane. In 1961, an unusual patent was submitted to the US government. One Peachy Brooker had an idea for a new type of aircraft, one that didn't just carry cargo, passengers, or had a military use in mind. Rather, it would be an everything plane. And the concept wasn't that far-fetched. There are car trucks that transport new vehicles, there are even boats that deliver fancy yachts around the world. So Peachy, as I like to call him, thought, why not aircraft too? And this, my friends, is the madness that he came up with. The flying platform was a squat plane that looked like it had been cut in half. Running along the top would be two parallel landing tracks that would have had small claws attached to them that could move freely, but I'll get to that part later. In the patent, there was extensive attention given to the support fuselage structure, which would be needed if it was to carry a fully loaded aircraft on top. Naturally, there would be no tail, but rather two horizontal stabilizers that would actually extend out during flight to better change aerodynamics depending on the load, an invention that I don't think I've seen anywhere else on any other aircraft. There would be two small vertical stabilizers on each of these rear winglets. The patent document would highlight that this would be a propeller aircraft. After all, it was 1961, but Peachy did mention that obviously there would be a jet-powered version by the time it got into the sky. The plane would also have 3 lines of landing gears, a typical one in the nose that could be steered, one in the middle, and then at the end of the plane for load-bearing tail strikes. As they were weight-bearing, they wouldn't have the ability to retract into the fuselage. Lastly, there would be a cockpit located in the front section where the small team would sit during operations, with a window to see exactly how close they were to their quarry. Also, there was a passenger compartment that could be used in case to evacuate a plane on board during an operation, which is just so crazy that I'm just going to talk about it right now.
Like posters, merch, and supporting a channel and creator who has made weekly videos for you for years? That's right, the Found and Explained merch store is open, and I've tried really hard to come up with legit cool stuff for aviation fans. So check it out and let me know what you think. Link below.
This is where the patent turns things up into overdrive. Upon hearing over the radio that an aircraft was in distress, the rescue plane would take off to perform a rescue. It would fly underneath the plane in trouble at a slightly slower speed and then allow the disabled passenger plane to fly forward, letting its landing gear roll over 2 parallel tracks. The landing gear would impact the forward arresting hooks that would snap close, and then the landing gear would fall into pits at the front, securing the passenger plane to the platform. At this point, if the passenger plane needed to be evacuated, if God forbid the plane was on fire or something, which is a real reason listed in the patent, then there would be a small chute or folding stairway that could be deployed. It's really not clear how this would work if the plane was going over 500 kilometers an hour, but I digress. Once the passenger plane was evacuated, the entire platform could be rotated at an angle of 15 degrees to allow the passenger plane to slide off, presumably on fire, into the ocean just like that. And even better, if it didn't slide off, there was a little auxiliary support arm that could be raised to, and I quote, urge the cargo to be jettisoned with a little push. Additional clamps could be activated to secure the aircraft if they wanted to go for a landing, and thanks to this flexible design, any type of plane or cargo could be secured. And then the plane would have additional braces that could be deployed to help with the weight loading. The whole plane would then presumably land safely. And I say that last word with air quotes. But an on-fire rescue wasn't just the only way he planned for this aircraft to be used. There were a vast number of other applications as well, just like catching missiles from the sky. While officially the object of this invention is to provide a large flying landing platform for disabled aircraft, Peachy had a lot of other ideas. For one, he saw this as an invaluable tool for space travel. An issue with returning spacecraft is that they need to slow down.
A challenge when sometimes they're going multiple times the speed of sound, but by deploying air brakes and a parachute, a spacecraft's landing becomes less accurate. So the flying platform would solve both these problems. Okay, so before you start writing in the comments about how dumb this whole idea is, I just want you to bear with me. A rocket would be re-entering the atmosphere and the landing platform would deploy a cable not unlike an aircraft carrier. The missile would deploy a trailing hook which would grab the arresting cable. This missile would fly over the plane rapidly and then run out the cable just like a fishing rod. The plane flying platform would slowly winch the missile backwards or while going 500 miles an hour and slow down the gliding rocket. Once it was going slow enough, the plane could then slide up and grab it. The advantage of this would be that the missile would only have to halve its speed and not have to waste fuel or design choices to bring it to a complete stop. And you thought that the passenger plane on fire was insane. In addition, we also mentioned its other various cargo uses, flying disabled planes around for maintenance, and its military applications. But I have one more little nugget for you. This plane was designed to fly vertical. Peachy, being a prophet before his time, had a few more tricks up his sleeve. He saw the writing on the wall that planes were going vertical, or VTOL, and knew that his invention would also need to be future-proofed. The patent mentioned that the lift would be augmented with vertical takeoff and landing propellers, or forward propellers that could swivel to provide that lift. In addition, helicopter blades were to be attached to the wingtips and folded away during normal operations, or perhaps ducted fans would be chosen and would be buried in the central fuselage, for sure making this idea one of the most flexible platforms to date. The flying platform, or the plane, is such a wonderfully insane idea, but something like this, had it been built, would have been very useful nonetheless. Oversized cargo, like that of the space shuttle, could have been easily carried, and its use for the military likely makes you gun-ho fans salivate. Although I do seriously doubt its ability to be used for rescue operations. The risk of collision with a plane that is out of control, after all it's in trouble, is so much worse than the risk of the plane trying to land itself on the ground. Imagine if the mission failed. In the end of the day, we never got the plane, and I wish it got a lot further than just a dusty patent and a YouTube video on your favorite channel. But I'll finish with this: the patent is actually expired. So really, there's nothing stopping you, yes you watching right now, from building it today. What do you think? Let me know down in the comments.
The aircraft you see on screen is different in one very big way. The wings are round. More specifically, the wings form a circle all the way around the fuselage, a closed wing, or more accurately, a ring wing, around the plane. This innovation, while at first looks like an AI-generated plane, is actually a design that is far more fuel efficient, generates more lift, and was almost the future of aircraft design. But the ring-wing commercial plane would be buried and never see the light of day. What would this ring-wing plane be like to fly? Why did we never build it? And whatever happened to the concept completely? Join us today to discover what goes around comes around in the world of wacky aviation. Like posters, merch, and supporting a channel and creator who has made weekly videos for you for years? That's right, the Found and Explained merch store is open, and I've tried really hard to come up with legit cool stuff for aviation fans. So check it out and let me know what you think. Link it below. Our story of the ring-wing aircraft has its roots at the dawn of aviation. Not the Nazis this time, of course, for those watching the channel for a while, but actually the French. An early example of the closed wing was on the Bell-Riot 3 aircraft built by Louis Bell-Riot and Gabriel Voussin. The lifting surfaces comprised of two annular wings mounted in tandem, and the later version replaced the forward annular wing with a biplane and added a canard foreplane to make it a three-service aircraft. It was able to leave the ground in small hops before being damaged beyond repair. But that leads us to the future with our hero of the story, Lockheed. Advancements in the ring wing concept, especially the French VTOL fighter aircraft after World War II, made Lockheed wonder if this concept could also be used for future fighter jets. But then they thought, why not make it a little bigger? It's the 1980s and Lockheed needs a new aircraft to beat back MD and Boeing for the trophy of the world's best commercial aircraft builder. So enter in our aerospace engineer star, Rollo Smethers. You might have actually heard of him before, as he's the brainchild of the Lockheed flatbed aircraft that we've already covered on the channel. So you know that this concept is just as wacky. But it's this ring wing commercial monster that he came up with that's the focus of today's video. And boy, it is one of the most fantastical aircraft I've ever had the pleasure of showing. With the title of the Ring Wing Lockheed Commercial Transport, it would be 52 meters long with a wing circumference of 7.4 meters. The wing itself would be a low mid-length attachment before arching backwards 27 degrees to attach itself to the tail of the aircraft. The overall height is substantial, reaching up to 23 meters, meaning it wouldn't really fit in typical hangars for, say, the 737. And with the blueprints, you can see just how low the actual fuselage is compared to the wing. There are two control surfaces along the tail to control the direction of travel, thanks to no flaps on the ring wing itself. On board, it would mimic the configuration of the Airbus A320 or the 737, carrying around 120 passengers in a 3-3 short-haul configuration, making it perfect for short-haul routes. Because of the fuel efficiencies of the design, it would be perfect for those commuter destinations that don't really reach high altitudes, such as New York to Boston, London to Manchester, or my personal favourite, Sydney to Melbourne. This concept reaches far as some media testing, like the article you can see here, and initial discussions with airlines. Naturally, these were just part of Lockheed's portfolio of innovative future ideas to make it seem like their stock standard designs were more futuristic. Now, I can't say for sure if any airlines ever really considered the ring wing concept, but you know that it definitely got a buzz. And alas, this concept never really went further than wind tunnel tests. Now, I should mention that Belarus got this concept working on a small crop duster aircraft, and it's nonetheless impressive. A few prototypes flew, but funding was eventually pulled by Russia and the project was abandoned. There is also another type of aircraft similar to this called the boxed wing, not a ring wing, and that is a whole nother video, because even Boeing is building a prototype one. If you want to see that, write in the comments and don't forget to click subscribe so you don't miss it. So I'm guessing at this point of the video you're wondering, gee Nick, this looks wacky, but would the ring wing actually fly? Well, let's dive into how ring wings work and you'll finally understand why we don't have this beast today. A closed wing system, where the wing loops around the horizontal axes and reconnects to the fuselage of the aircraft, has several major advantages. Because the plane doesn't have actual wingtips, that means wingtip vortices and the downwash of the wing that they cause are nearly eliminated, and the wing can generate more lift, meaning shorter runways, less fuel, and no impact on crosswinds. A triple win. Well, kinda. While Rollo was imaginative for sure, he was a little bit more loose on the physics of aviation. While a joined wing aircraft provides significant induced drag and structural advantages, they also suffer from increased parasitic drag and require careful design to avoid issues like flutter and boundary layer separation. Essentially, in layman's terms, the fuel saved from the increased lift is cancelled out by the increased drag. Now, this is something that is not apparently obvious when you're using wind tunnel tests, because a lot of the time the wings used on these planes have an infinite aspect ratio, exactly the same as a circular ring wing, something that they quickly discovered in the 1980s. We also have to mention that the weight of having a whole nother wing on top, essentially like a biplane, just adds to the weight of the aircraft, and then you still need more fuel. In addition, there is also something called a wing twist. You might notice that on modern planes, the wing isn't flat, but rather twists away slightly from the fuselage, specifically a twist to the wing where the onboard position is at a higher angle of attack than the outboard. This means that your onboard will stall before your outboard, which has the control surfaces, and thus you can recover from a stall. Such a system wouldn't work on a ring-wing plane. The benefits of this design outweigh the drawbacks only if the aircraft is well optimized for the mission, such as short runways or heavy crosswinds. But that's not all, we also have to talk about money. Designing a joined wing aircraft requires strong interaction between different disciplines such as structures and aerodynamics. This makes it difficult for the normal team of engineering specialists to optimize the design. Additionally, this type of design is not well understood or mature as conventional planes, which makes it more expensive to achieve all of those potential benefits. Therefore, an established manufacturer may choose to stick with what they know and what the customer is willing to expect instead of designing some crazy new concept. In summary, there's a reason why we abandoned biplane designs. Just like the ring wing, it's not the most efficient. But that didn't stop Rollo Smethers, Lockheed visionary and aviation pioneer, from imagining the impossible. He would unfortunately be taken from us much too young due to cancer and would never realize many of his designs, and I thought, why not dedicate this video to him and the many other forgotten builders of a future that we could have had. This one is for you, Rollo. Thanks for watching. Flying around the world is a gigantic nuclear-powered airship. But it's not a weapon of war, but a tool of peace, teaching the world about the power of the atom. But it was far more than just an experimental flying fission reactor, but more like a city in the sky, with a vast hotel, a sky promenade, a heliport, and even a raging nightclub. I'm not kidding, it even had a bar and nightclub that was included specifically on the blueprints. This Atoms for Peace airship was not only a fantastic vision for a brave nuclear-powered world, but one that would have relaunched dirigible travel as a fantastic flying cruise ship alternative to jet travel. This is the atomic dirigible and the world of tomorrow that we never got. So how the heck did the US government even reach the point that they wanted to have a flying nuclear-powered blimp? The story is more nutty than you might think. The year is 1953, and the Second World War is over, but a new one is brewing. While America had a few years as the only nuclear power in the world, the Soviets successfully tested their own nuclear weapon in 1949 and has once again reshaped the balance of power. America would not only need to reaffirm itself as the leader, but also seize the budding atomic market. Thus, the Eisenhower government came up with a new policy: reach out to satellite nations, particularly those falling under the influence of the Soviets, and introduce them to the American way through peaceful use of nuclear energy. This was called the Atoms for Peace program, and they intended to share non-military nuclear technology, training, and materials with friendly nations. But how? After all, a nuclear power plant isn't something that you can just pick up and move. But fortunately, as luck would have it, the Navy had already figured it out, with a nuclear-powered submarine. To beat the Soviets as quickly as possible, the US government intended to take the nuclear reactor from the new submarines and stick it in a civil ship. But that technology at this point was increasingly becoming obsolete, so then the thought was they would need a new vessel. And if you're going to spend billions today on a ship, why make it an ocean-going vessel at all? Enter the atomic airship. As the debate raged on in Congress as to what the Atoms for Peace ship would look like, Mechanics Illustrated and Goodyear Aircraft floated, pun intended, a unique idea. Why should it be an ocean-going vessel at all?
Their proposal was a vast floating city, dubbed an Angel of Peace, and the logic made a ton of sense. For one, a ship would only be able to move over water. An airship would be able to reach the ocean of the world, the atmosphere, and seas, mountains, and deserts would present no obstacle, as well as being able to reach landlocked countries. As it was a peaceful mission, there should be as little barriers as possible, or so the thought was. In addition, this design would be impressive as hell. It would showcase the very best of American technology at the time and totally fill up the sky. Imagine it traveling over remote regions or arriving at a nation's capital, showing that America had the reach and power and should be listened to far more than those smaller Soviets. And just how impressive would this airship be? Just look at it. At over 1,000 feet long, it would have 12 million feet of helium capacity and be able to carry over 100 tons. The hull of the dirigible would be made up of modern materials for the time, such as titanium and lightweight fiberglass. The idea was to go as light as possible so more weight could be given over to the other parts of the airship. This new improved weight to strength ratio would allow for the addition of extensions. Essentially, instead of going for one gondola running the length of the blimp, there would be extendable kneels like a catamaran holding more cargo and passengers. As this was a modern blimp, there wouldn't be any docks for biplanes, but instead have a helicopter hangar. This hangar would be located on top of the blimp with a sliding door to allow for all-weather operations. The pad itself would be an elevator and rise up to release the aircraft to the elements and lower down to discharge passengers in the now weatherproof closed hangar. The helicopters could then provide a ferry service to the surface below, carrying fresh food, passengers, and cargo, useful when the blimp couldn't land. Speaking of landing, this blimp was also designed for dirt and water surface landings. Remember those retractable kneels that we mentioned before? They could also be fitted with inflatable rubber bases that would inflate and be little pontoons for the airship to rest on. To ensure that the blimp wouldn't fly away when it was on the surface of the sea, a hose would pump up seawater as ballast to hold it down. And when departing, they would just discharge the water back into the ocean like a reverse submarine. One flaw of airships in the past was the speed in which they flew, but thanks to the power of the atom, this could be relatively increased. The middle of the blimp, there would be a twin atomic steam plant that would generate electricity and then transfer the electricity via light cables to a 4-bladed reversible propeller at the rear. There would be no fuel requirements, sans uranium, and thus the whole contraption would be light. With 2 turbines, the blimp would always have access to power. There would also be ducted fans throughout that would rotate on gimbals to assist with vertical movement and move sideways to counter any windy conditions. But I know what you're going to ask at home, what would it been like to fly on board? As the mission of the Atoms of Peace dirigible was to show off atomic technology, guests were encouraged to come on board, and boy was this to be quite the la-di-da experience. First, passengers would either arrive by helicopter as mentioned, or they would board via the exhibition hall. This hall actually had the ability to lower down on cables and even could be detached, and then retract back up when everybody was on board. The hall would also feature a museum on all things American and atomic, and act as the traveling World's Fair at the time. Guests would then move to their passenger cabins located around the middle of the blimp on its horizontal axes, with balconies and sunrooms. There were several public rooms along the base of the ship, with lounges and cafes to see the world drift by below. As there was complete access on board, there would be a viewing gallery around the atomic reactor to let visitors see just how powerful America's technology was. And I guess, judging by the lack of protections, get a healthy radioactive tan as well. There was even mention of a fishbowl type reactor that would use a transparent glass and water shield to allow people to see the reactor at work. Lastly, on top, there was a promenade deck to see the stars above and a nightclub and bar in the rear. Did you think it was just American science that this thing was showcasing? Not at all. This blimp would have had shows just like Las Vegas as it drifted over the world. To get around the ship, there would be an elevator to the front and rear of the aircraft running through the main fuselage. The bridge and powerful radar dome would be located at the front, and there would be an after bridge in the neo of the aircraft. amazingly impressive, and perfect for the mission of peace. So why was it never built? Goodyear would present this idea to the Atoms of Peace Council, stressing that this was the best way forward. They linked it to a recent proposal by Max Pruss, the former captain of the Hindenburg, who had said to the West German government that dirigible would be the first to use atomic engines, and because it is the only aircraft capable of carrying the weight. However, everything changed when the United States actually started to put the plan into effect. They reached out to third world countries, those not aligned with the US or USSR, and tried to establish some bilateral agreements to develop nuclear power, asking them to contribute financially to the program with resources as well as money that would fund this ship. US officials hoped that the propagandistic potential for the Atoms of Peace program would strike a critical blow in the Cold War, but nations in Asia and South America responded to offers of American aid in an unexpected way. Particularly, they intended to stake out their own claims to the new technology of atomic power, challenging US dominance in the process and ultimately redirecting the Atoms for Peace program. These nations, after all, realized that this airship program would only really serve the United States as a tool for propaganda and not actually bring them the freedom that they so craved. As the first nation in South America to build a nuclear reactor, Brazil was something of a test case for the Atoms of Peace program that ended in dissatisfaction on both sides. While the research reactor in Sao Paulo was the first nuclear plant in Latin America and represented a significant achievement for both Brazil and the United States, the collapse of plans for a power plant was a notable failure. The dream of a nuclear Brazil in the 1950s floundered on the dismal economic prospects for nuclear power and internal political divisions within Brazil over the appropriate degree of cooperation with the United States. Their experiences in Asia and Brazil led US officials to question the efficiency of nuclear power technology as a tool of foreign policy and development. In layman's terms, these nations didn't want to rely on America for the atomic future, and this lack of political gain for the US government made them question the whole thing. Over the next 3 years, American ambition slowly waned, and there was a lack of support from both the State Department and the Atomic Energy Commission, and Asian nations continued to resist American pressure to commit money and resources to join in on the project, especially with the result of the Korean War and Vietnam War making America seeming like a bully in the region. The program was officially terminated in February 1959, and the incredible flying atomic city was never built. Let me know down in the comments what you think and if this dirigible should have been built, and if I've mispronounced any words in today's video. Thanks for watching.
All new at 6, you might soon be able to go on a sky cruise. Designers are working on a new aircraft that uses 20 nuclear-powered engines and artificial intelligence to fly around.
So you probably saw the incredible flying hotel concept all over the news, TikTok, and the internet. But it's completely baloney. This isn't the first time that the fast-paced mainstream media has been completely hoodwinked, like here with the flying helicopter hotel. But this version of the flying aircraft was certainly the biggest. And seeing how big this aircraft was and how big it got on the internet got me wondering, is a flying hotel even possible? Let's explore the Sky Cruise concept, how it fooled the media, and what a real sky hotel would actually look like. All aboard the Sky Titanic. This week on my other channel, I have a video about the Nazi Sun Gun, a super weapon that the Nazis designed to evaporate New York. Check it out after this video, link down below. Like with all viral news, this one has a humble beginning. Back in the far-off year of 2012, an artist by the name of Tony Holmston created an art series
called Killer is Dead. In it, he featured what can only be described as a Miyazaki-era Laputa in the sky creation that seems to defy gravity. While impressive, it's our next artist, Alexander Chukov, who turned it into a 3D model. It's been so popular that he's increased the price up to $500. Now, credit where credit is due, the 3D is so good that it fooled the world. And now enters our hero of the story, or perhaps interloper, Hashem Al-Ghali. As part of some world building on Reddit, he used this model to describe a fantastical flying hotel. One that was described by the media to carry 5,000 passengers all over the world, with luxury that isn't even found on cruise ships. Everything from restaurants, shopping malls, hospitals, and even a 360 sky deck. Such a large aircraft, of course, would require a power source that is equally bonkers: fusion nuclear power. With near unlimited nuclear fuel, it could fly forever and never have to land. Which, by the way, is the same concept behind the equally insane Lockheed flying aircraft carrier, which I covered right here on the channel, which you can watch right after this video. To ensure safe passage on board this sky hotel, the plane would use a state-of-the-art artificial intelligence to pilot the craft and navigate turbulence, using what the author describes as noise-cancelling technology. Passengers would fly on converted 747s powered by electric motors from the ground up to the sky cruiser to dock, and then from there experience the very best that the Earth and sky has to offer. Leading us to the viral moment. After trending on several different parts of Reddit, it got picked up by the media, who went to town and assumed that engineers from no other than Germany were working on this concept and that it could be flying in our skies within the next 10 years. They also outrageously claimed that the first airline to run it would be Dubai's Emirates, and that they were even making orders. Something that really puts to show how little research some news organizations do. It's not the first time that the media has fallen to the hype of a flying sky hotel. Back in 2009, the media was tricked that the MiL-12, the world's largest production helicopter, had been bought to be turned into a helicopter hotel, or dubbed the Hoteliocopter, which I think is a pretty fascinating concept. After all, imagine trying to sleep with the rotors on. So what would have it been like if this sky hotel had actually existed? Well, for one, there are all sorts of engineering questions, let alone understanding the laws of thermodynamics, that we need to take into consideration when talking about this plane. The first is the power source. Fusion energy doesn't exist, and nuclear power, even fission, on board a plane is an immature technology. I've covered it in detail, the experiments to build a nuclear-powered bomber, and while in theory it's something that's possible, it might not be exactly what you want to do. After all, you can imagine if something went wrong, you'd be spreading nuclear fallout over half of the country. With 5,000 passengers on board, you would also need to absolutely make sure that the radiation shielding is up to spec, and that there is a safe way to evacuate all these passengers within 60 seconds on the ground in order for the aircraft to be approved by the FAA. Other questions that I raise are about where on earth this aircraft would take off to begin with. Perhaps it would have to be some vast runway built out into the middle of the desert somewhere. And then plus, how would they get enough food and water for all 5,000 passengers? Even the best aspirations would require more than just enough for a typical meal on board a plane, especially if it's supposed to have the type of dining that you would expect on a cruise ship. And lastly, we didn't even mention the cost to build such an aircraft, and nor the engineering technologies that would be needed to build it. But there's one gaping question I have, and that's, would you even enjoy being on board?
If you're like me and if you've flown long haul across this planet, there isn't exactly a ton to see once you're up in the sky and flying. I'm not saying that the view isn't utterly spectacular from an aircraft, but while you're flying, you're just kind of looking at clouds. Any landmark or site would be quickly flown by, and you would blink and miss it, an advantage that our humble cruise ship has over this aircraft design. As one Redditor said it to sum it up, I would like a Zeppelin, but more expensive, more difficult to operate, and much more dangerous. But let's just imagine for a second that you absolutely love the idea of a sky hotel. How would we actually make one with today's technology that could actually exist? Sky hotels, or as I'm defining them, hotels that are flying and can move around like cruise ships, are not exactly a new concept. The closest we ever got was in the age of airships. Introducing the flying hotel from 1930 that was simply incredible. Looking at the concept in detail, there was an opera house at the front of the airship, ballrooms in the middle, followed by large cabins with actual beds and baths, as well as an airport at the rear. Yes, that's right, you didn't mishear me. That's an airport within the rear of the airship that planes can be flown up and towed on board and then deliver guests to their rooms. It was designed in such a way that the airship could slowly cruise over America, picking up passengers from smaller towns and cities before departing over the ocean, letting people fly to regional airports upon arrival. Let me know if you want me to explore this incredible concept a little bit further, or the Sky Hotel of yesterday, down in the comments. So what about today? Well, it turns out there is one other concept in development that hits the nail on the head. Called the Airlander airship, this concept is bringing back the slow but fascinating travel of yesteryear. Ocean Sky Cruises airship is a 100-meter long hybrid aircraft combining buoyancy from helium with aerodynamic lift created by the shape of its hull. Driven forward by 4 propellers, this vehicle can fly continuously for days and would be powered by low-emission energy sources. The aircraft wouldn't fly higher than 10,000 feet in normal operations, so there wouldn't be any need to keep the cabin pressurized. But where do they intend to fly this type of aircraft? The first trip would be to the North Pole, where 16 passengers can get off and explore thanks to the ability to land and take off without an airport. They'll also be served meals from a chef based on the region of travel. Pretty fantastic. The company believes that these airships will allow people to travel to remote corners of the world without impacting large carbon emissions and without leaving a footprint like cruise ships. Perhaps the Sky Hotel isn't such a bad idea after all, but it looks like we'll need to gaze back at the past instead of visioning into the future for how it would work. What do you think? Let me know in the comments, and thanks for watching. What will an aircraft cabin look like in the future? A utopian experience with onboard spas and golf? Or perhaps a utilitarian nightmare with triple-stacked bunk beds and standing saddle seats? Let's count down the best new cabin ideas and what it will be like to fly on tomorrow's aircraft. Hey, it's me, Nick here from Found and Explained. We have a whole lot of new people joining the channel, and I want to say thanks for coming. And if you haven't already yet subscribed, then maybe you will. It's free, and you can cancel at any time. Aircraft cabins have come a long way. Back in the golden age of aviation, there was not even classes, and many people sat with the equivalent of a business class seat today. Over time, new classes developed and luxury was given to more premium passengers, while the economy cabin became denser and was packed to the rafters. However, it doesn't always have to be that way, and aircraft designers are looking at ways to bring back some of that golden age splendor to plane cabins today. Starting off our list is an aircraft cabin design from Airbus themselves, called the Space 2030 concept. Integrating augmented reality throughout the cabin sees Airbus creating an environment that is designed specifically for flexible seating and sleeping configurations. It will have things like an in-flight lounge with transformative modules, with the cabin layout changing depending on who has booked what seats. There will be digitally enabled crew operations to help facilitate better personalized service, and in some cases there will be automated services that can deliver products without cabin crew. This will all be powered by a personalized passenger augmented reality, focusing on passenger well-being and atmosphere right from the unique welcome and streamlined boarding process. Airbus has also previously featured an interactive zone. The virtual pop-up projections in this area can transform you to whichever social scene you want to be in, from holographic gaming to virtual changing rooms for active shoppers. You might even be able to work out, although without showers on board, it might get very smelly indeed. Other items include baggage management for passengers, surface lighting throughout, which looks very cool, and say goodbye to windows with high-definition virtual outside view. Speaking of windows, many future cabin concepts are removing windows as they are a weakness when it comes to aircraft design. Not only do they add more drag to the plane, increasing fuel burn, but as soon as an airline perfects the virtual window, which are infinitely bigger than real ones, or that they allow passengers to change the view on a dime, like we have on the Spike S512, which you can check out a full video of this aircraft on my channel, then windows are as good as gone. Plus, with no windows, now you can have truly creative cabin concepts, such as a sky bridge at the plane's front, allowing you to fly through the sky. But what about low-cost carriers like Ryanair and EasyJet? They want to pack as many passengers on board as possible, and these spacious open floor plan designs don't quite work for them. Introducing the monstrosity de Lift University of Technology's collapsing bed concept. In seat mode, these beds collapse into a bench that can sit 3 passengers. Then after takeoff, they can deploy into a triple stacked bunk. The same designers also came up with an alternative bed along the wall design that can replace those boring window seats with triple-decked lie-flat beds in economy. But I hear you say you want more people on board. For that, we have the Chase Lounge design with passengers suspended on swinging chairs above one another. This design doubles the number of passengers on board with double seats per row, sitting literally above one another. The seat will be able to rock back and forth depending if you want to sit or lie down. And it gets worse. We can't leave these crazy designs without mentioning the standing seat design from Every Interior's Skyrider. These saddle-based standing seats only have 23 inches of legroom between rows, which would allow operators of short-haul flights to truly turn planes into flying buses. Would you fly on a plane like this? Let me know in the comments. And then we turn to the question of the cargo cabin. On ultra-long-haul flights like London to Sydney, do aircraft need to use an entire cargo deck for cargo? After all, cargo doesn't really care if it's flying a 24-hour flight or if it's taking a few days, whilst passengers do want to get there as soon as possible, as comfortable as possible. So why not use the third deck for private cabins, spas, business meeting rooms, or perhaps even an onboard gym? The Earth Bay cargo hold conversion design sees it transforms the area with large windows and a relaxed common space. So far, Airbus has pitched the concept for its Airbus A350 to Qantas, but we have yet to see if the Australian airline will bring these cargo conversions to the market. Some other concepts that didn't quite make this list include the Collins Aerospace cabin crew jump seat, allowing flight attendants to rest in a zero-G experience. Then there is also the Heinkel Group's reversible commuter seats, allowing groups to chat together, which is very similar to the Q-Suite business class design we see on Qatar. However, all of these designs mentioned so far need to be overhauled in the age we live in today, where personal space is at a premium and some people put their lives on the line to travel around the world. British firm Priestman Goody has imagined a future scenario and taken into account new passenger behaviours driven by the global crisis, coming up with a design called Pure Skies that can be implemented within a few years and will meet user and airline requirements for many more years ahead. These concepts feature a completely redesigned economy cabin, with staggered seats that are separated from one another so that passengers can travel alone, or as a couple, or as a group. They have placed a divider between each row to give the sense of privacy and protection, and as in-flight entertainment is a major touch point, it has been removed in favour for a passenger's own device. But the real experience is in the Pure Skies business class cabin. Featuring something that looks like a massage day spa, each seat is separated by a curtain and kept away from the hustle and bustle of the cabin. The seats have a minimal split line with no cracks and is created from materials that have antimicrobial materials. Passengers will have control over lights, temperature, and have a personalized wardrobe for storage. Cozy indeed. In fact, this plane design is so hygienic that before boarding, the aircraft fills with fogging disinfectant and has ultraviolet lights sterilizing a good chunk of the environment, making safe planes even safer to fly today. Thank you so much for watching my video. What did you think? Which cabin concept is your favorite? Let me know down in the comments below, and if you enjoyed today's video, then subscribe. What is the perfect commercial aircraft? Is it a long-haul 600-seater like the Airbus A380, or is it the smaller 100-seater narrow-body like the Boeing 737 MAX? Well kids, grab your pencils because today we're going to sit down and design the perfect aircraft. Hey, it's Nick here from Found and Explained. If you like planes and other tech things too, then you'll love this channel and I invite you to subscribe. Let's get into the video. This video will be a little bit different from my others in that we're going to be designing the perfect aircraft together. What do I mean? Well, imagine we're making a new company called Found and Explained Aerospace, and we're going to go head to head with Airbus and Boeing in the commercial space market. This means we need to make the perfect plane that not only passengers will love, but will also win the hearts and wallets of our airline customers. So how will a non-engineer and his family of subscribers on the internet build an aircraft? Easy, through answering several questions. Let's begin. Question 1. Passenger capacity. The first question we need to ask ourselves is, what is the most popular passenger configuration? If you're new to planes, you might think that bigger is better, like the famous Boeing 747 or the double-decker A380. However, this could be further from the truth. The two most popular aircraft currently available in the world are the Boeing 737 and Airbus A320. There are many variants of the type that we won't go into detail today, but we have seen a trend of these aircraft becoming bigger over time, reaching towards a passenger capacity of around 200 to 230 passengers. Thus, we could rightly suggest that our perfect plane should comfortably seat 200 to 250 passengers in either two-class cabin or a 250 in an all-economy cabin. The passengers will be seated in a staggered 1-1, then 2-2 configuration in business class, just like what's found on JetBlue with its Mint business class, 2-2 in premium economy, and 3-3 in normal economy. The aircraft will be big enough to be profitable on such routes as Los Angeles to San Francisco, but small enough to fill up compared to more expensive long-haul aircraft. Question 2. Range. Let's talk about range. As mentioned before, the best-selling aircraft have a range on average of around 4,000 nautical miles. Our perfect aircraft is going to push that and fly around 5,000 nautical miles, enough to open up routes from London to Cancun, Singapore to Istanbul, and Los Angeles to Tokyo. But this aircraft won't be designed for hub-to-hub travel, but rather from small airports to small airports. This means flights from cities like Boston to Heliklion, Greece, or Sydney to Sri Lanka, routes that don't make much economical sense for large flag carriers, but could easily be incredibly profitable for cunning, low-cost operators or smaller national carriers. The third question will be narrow body or wide body. Speaking of economics, we need to discuss the difference between a narrow body plane and a wide body aircraft. A wide body aircraft, characterized by its twin aisles, has more passenger seats and is more comfortable for long haul flights and can carry more cargo. Typically, wide body aircraft are the Boeing 787 and the Airbus A330. A narrow-body aircraft has a single aisle and is more fuel efficient than the A330, but is more cramped and not that suitable for long-haul flying. There are some ways to combine these two types together, like I explained in my previous video about the Boeing 7M7. However, for our purpose, we'll only go with one, the cheaper to operate narrow-body. Sure, it won't be comfortable, but passengers won't mind because of the low ticket price. It'll be quieter and be more environmentally friendly as well. Oh, and it goes without question that this aircraft will only have 2 engines, as a 4-engine aircraft burns way too much fuel for our purpose. And I would love to say that it also flies as fast as a Concorde, but thanks to supersonic laws, we have to fly slow and steady at normal aircraft speeds. Now, question 4, we need to discuss cargo and cargo capacity. The cargo capacity question is a little bit tricky. If we go with a narrow body choice we just made, we are going to severely limit the cargo capacity of the aircraft, as the hold will not be able to take LD3 containers. That being said, we'll offer a cargo version of the aircraft with a tail door. It is important that the aircraft's tail opens like the Boeing 747 nose door, so cargo can be loaded in quickly and without having to perform a 90-degree turn. So the last question, number 5, who will buy this plane? This aircraft will target the transatlantic and Asian Pacific markets for low-cost carriers to compete against flag carriers and make international travel cheaper. As it's designed for long, thin routes, we will finally see highly profitable low-cost carrier base itself off this aircraft. Of course, this plane is going to have plenty of disadvantages. For one, the passengers are going to hate the tighter conditions on board, but they will find that the seat width will be wider than on average than on a wide-body aircraft with a 3-3-3 configuration. With a premium economy cabin, passengers who don't want to share their row can sit together, and economy is not dissimilar from that found on a 737 or A320. One of the issues will be turnaround time, with the plane taking longer to turn around than its small 737 competitors, which may make it unsuitable for short-haul routes. There is also the question of the cabin crew rest times and how meal service will be conducted with a single aisle. There will have to be a blanked out section for the cabin crew to fly long-haul routes, and plenty of bathrooms on board that can be accessed by different cabins. You might be watching this video and thinking that all of this sounds awfully familiar, and that's because it is. This is essentially the same aircraft as the popular Boeing 757, which back when it was in production, sold over 1,000 units. Today, there is no aircraft under production quite like it, and if it was built, I think we could easily see orders for at least 1,000 units. And this video might be closer to the truth. Back in May of this year, Boeing was reportedly working on a Boeing 757 Plus aircraft based on the 757-200, which they would quickly bring to market to rival the success of the Airbus A321 XLR. Alas, the current market conditions have slowed such an idea. What do you think? What changes would you make? And what would be your perfect plane? I can't wait to read your comments, so write them down below and I'll answer every one. And if you enjoyed this little opinion video, then subscribe. Thanks so much for watching.